project. Actually, we went into incubation last year in November. It's a framework for working with textual requirements. And one of the things that's kind of novel about this is that it is based on a relatively new international standard for exchanging requirements called RecIF. Anybody here heard of RecIF before? Okay, very few. I'm going to show a few features of the RecIF model in a second. But about the project, it consists of two big pieces. One is the core, an engine that can deal with the data model, that can persist it, and so forth, and the user interface that we call ProR, which allows users to interact with the requirements, and that's something that you're going to see in the demonstration. RMF is based on two academic projects, one called Verde, the other one called Deploy. So the roots are in academia, but from the very beginning we designed this framework to be used in industry. So we think it's quite useful in that way. It started early 2010, went into incubation November last year, and we've been doing integration builds ever since. So you can go to the website, check out the current version of 0.2.0. Okay, this is a rough overview of the architecture. So you have Eclipse underneath. We use the Eclipse modeling framework. One of the reasons is that the standard already provides us with a model that we could just massage into an eCore model to generate all the code for this project. Very convenient. On top of that, you have the meta model. That is basically the model that represents your requirements. And I'm telling you a little bit about that model in a second. And then on top of that, you have the user interface. And of course, we provided a number of hooks in various places so that you can extend it. And in the demo, you will also see how we do the integration with other models to take advantage of those hooks in the system. So this diagram has been taken directly from the RecIF spec, and it gives you an idea of what the major features of the RecIF data model are. So basically, you want to work with requirements. You probably all know what the most commonly used requirements engineering tool in the world is. Word and Excel, Microsoft Office. So requirements, basically, you have a textual representation. They're usually individual units. People who manage the requirements, like very primitive with Excel, have multiple columns, multiple attributes. That's basically where often people start with doing the requirements. So the standard is based on industry tools that use much more sophisticated data models. So this is the RecIF content, which holds all the data of a RecIF model. And you first have spec object. The spec object is a requirement. In RecIF, a requirement doesn't have any information whatsoever. The actual values come from attributes. And what attributes a spec object has depends on its type. So in other words, you say, well, I have a requirements type for this or that, and then you basically define a type which says what attributes you have, typically like a textual description, an ID, maybe a drop-down field of the status, whether it's approved or rejected or pending or something like that. So there are a number of elements that allow you to define the data types that you can then actually use in your requirements. So in other words, you have these spec objects. They have attributes as you define them. What you also have is spec relations, which are links. So in other words, you can connect requirements with each other and create a traceability. And these links can be annotated. They also have a type, so they can also have attributes. And last, we have a specification, which is kind of, in quotes, the document that holds it all together. So a specification consists of a tree structure of spec objects. So in other words, that is how you arrange your requirements in relation to each other. You have a tree structure, so you have nesting and so forth. So this is, in a nutshell, like a very broad overview of what's in a RecIF file. I mean, there's much, much more from permissions and some other things. Okay, so this is the ammunition that I wanted to give you to follow the demonstration that I'm going to give. So in the little time that we have available, I want to basically specify the system, traffic light system, and also build a formal model that represents it and establish traceability. So not much time for that, but I guess the problem is clear to everybody. an intersection with the traffic light system. So with that, I want to switch over to the environment. What you see here is actually a modeling environment that has RMF installed into it. So in the first part of the demo, I'm not going to do anything with modeling. In the second part, we're doing the traceability. So we can start by just creating any kind of project. In this case, I'm going to use the model project. Just use the defaults because of the time. And in here, I can just create a new RecIF model, although I'm using one that allows traceability later on. Just going with the defaults. Okay. And so there you see an editor, which is kind of the entry point to working with requirements. It contains a number of document properties, and it lists all the specifications, what I just explained. There's just one specification in here. Let's have a quick look at the outline. So you see you can unfold here all the specifications. Here are the so-called requirements, the spec objects. There's only one in here. In the specifications, you can unfold further and see that the system, as a default, starts by creating one specification with one element in it. So let's have a look at that. This is how it looks like. You see an ID. Now we have a screen problem, so I think that's better. So you have a description field. So this is the pre-populated first requirement. We want to specify a traffic light system. So basically say traffic light for the cars has the colors red, yellow, green, right? So this is the first requirement. And now we want to say a little bit more about the system. So we right-click, and you can create either a child object, because we have a tree structure, or a sibling, and we can pick the existing requirements types. Remember, I told you there are types for requirements, which determine which attributes one has. And I just create another requirement and basically say the same thing about the pedestrian traffic light. So the traffic light for pets has the colors red and green. And just to make things interesting, we want a safe system. After all, we create another one. You can also use keyboard shortcuts like that. So the lights must not be green at the same time, right? So like a very simple system. So this basically shows you how the GUI looks like, fairly intuitive. You can do just rearranging with drag and drop, so like that, for example. You can actually create traces between two requirements by, hang on a second, by dragging and dropping with a special character like that. Then you see the link column shows you how many incoming and outgoing links you have. You can show them like that. Now they're visualized. So I don't have time to go into detail, but you get an idea of the system. There's an editor that allows you to see all the different types that the system have, to create new ones. Here you see that our requirement type has a description and an ID. Those are the things that you have been that you saw so far. So I'll use undo to basically go back to the original order of the requirements. So far so good. Now you get an idea of what the system can do rudimentally. So next thing I want to do is I want to show you how we integrate these requirements with a formal model that manages to represent these requirements. So don't get afraid. The formalism that I'm going to show here is called Event B. It's a formal modeling environment, a modeling language. It is state-based. It allows to articulate invariants, things that have to be true always. And then it can even generate proof obligations and try to prove them itself to show that those invariants are never violated for the specified system. Now, I don't want to convince you to use formal methods, because what is applicable here, you can also do to a degree with other formalisms. Let it be UML or SysML or whatnot. So I'm using this formalism simply because what you're seeing here is the result of some research, and we built this integration based on this formalism. So don't you worry, you don't have to understand the formalism. This is just to show the concept. Another thing is the theory behind the traceability that I'm going to show you is much deeper than what I'm going to show you because there isn't that much time. So I'm going to show you how traceability and traceability support is realized in this tool integration, but there is a theory that's behind it that I don't have the time to talk about. So having said all that, let's build a formal model that realizes our traffic light system. So this is how far we were. In order to do the formal modeling, we have to create first what's called actually I have to start elsewhere. The place where I want to start is by looking at the requirements and preparing them for formal modeling. In our theory, we have something that we call phenomena. And phenomena is anything from a state to a variable to whatnot. And we can mark phenomena simply by squared brackets. And now you already see the first aspect of the traceability that we realized. So you see that all these elements are in red because they haven't been modeled formally yet. So there you have like an immediate visual clue to an unfulfilled traceability. So to realize the traceability, we create those constants by creating a new component. And again, I mean, you do not need to know all this because this is just the formal modeling language. So we create a context. Here we go. And we basically say we have constants, red, yellow, and green. In this formalism, we have to assign them to a set, which we call colors. And you basically have to say that the colors belong there. So we create an axiom and basically say that there's a partition of colors consisting of sets red, yellow, and green. Okay, so again, I mean, this is not relevant. I mean, all you have to know is basically that I created some domain objects yet. So let's go back to our requirements. And you see that the color already changed. And not only that, if I go in here and edit this requirement, when I'm going in the edit mode, the tool tells me, hey, look, there are some keywords here that I recognize, but you didn't mark them as phenomena. So I can go in here and basically say, okay, this is also something that belongs to my formal model. So this allows us to do some modeling and adding and improving the requirements at the same time. So this is the first aspect of the traceability that we have. So not for the next aspect, and that's basically the dynamic aspect and the actual linking of requirements to model elements. So now I basically found those phenomena that are part of the formal model. But if I go to my formal model, then you see that this here is actually, oh no, actually, you know what? No, I'm ahead of myself. I first need to model the traffic light, and then I can link that. So that's the part of a live demo. So basically, we want to introduce the traffic lights. So let's do that. In the formalism, we have to do that with a so-called machine. Let's create that. Okay, here we go. And here we create variables, and one for the cars and one for the pedestrians. That's what I wanted to do. And in the formalism, you also have to type these, and that's basically where we're going to use the traceability. So we create an invariant, and we use the invariant for typing. So we basically say TL cars is an element from colors, right? So everybody with me? And the same we can say about the pedestrians. Okay. Why? Oh yeah, it gives me an error message because I have to tell it to see the context. Okay, very good. Just ignore the warning, that's normal. So now we have these invariants, and these correspond to our requirements here. So let me take this one away. So the traffic light for the cars had the colors red, yellow, green. This was expressed through this invariant here, which I can then simply link with drag and drop. Okay, so now I created a traceability, and let me make this like a little bit smaller so that you can see more. Here, now I created a traceability between this requirement, the traffic lights for the cars had the colors red, yellow, green, and this is an invariant. And if you want to see the value of that invariant, we click on it, and down in the properties, it shows me, well, teal cars is an element of colors. So we can, in the requirements environment, directly inspect our model elements. And I mentioned before, traces can be annotated. So I can just say here, this is the typing invariant. So this is now, this text belongs to the trace. Again, I can show and hide traces as I want to. So the same thing we can do with the second invariant, which goes here. And now I can see here the requirements text. And let me show the invariant. Oops, a little problem. Anybody sees the problem? Well, what? That's right, yes, yes. The traffic lights are just red and green, but in our typing invariant, we include yellow. So let's fix that. Let's go back to the model and say, well, no, here with the pedestrians, we don't want to have the color yellow. So take that out, save it, go back to the requirements. Notice something? So now, suddenly, we have a little exclamation mark here. So this is where we see the traceability directly in action. So the traces track the source and the target of a link. And now it tells me, watch out, the target of this particular link has changed. So better inspect the trace and make sure that it's still a valid trace. So I can then click on the invariant, see it down here, look at the requirement appear. I say, OK, this is valid, and dismiss it by double-clicking it. So just to make the example complete, we have one more requirement. And this one actually it's possible to express it fairly simple with an invariant. So the traffic lights must not be green at the same time. I can go in here and create another invariant and say not. So the traffic light for the cars equals green, and the traffic light for the pedestrians is green. And we are lucky because this invariant, sorry? And yellow, well, yeah. It's a simple example, not the real word, right? Yeah, I mean, I tried to make it, you know, like very simple here. But yeah, I mean, if you would want to make this a real example, you'd have to reason about colors versus what the colors mean and so forth. But let that be sufficient for this example. And now I can take the third invariant and create a traceability. Yeah, here we go. And now we basically have like a very simple specification with 3 requirements, with the traceability between the 3 requirements and the formal model. I mean, yes, of course, it's a simplified example, but I think you get the idea behind it. So with that, I want to conclude that demo. And I'm actually not too bad doing on time. I'm actually quite happy with that. So, I mean, what I wanted to show you here is that an integration is possible and that an integration can be seamless. We integrated the model and the requirements with drag and drop. We visualized model elements directly in the requirements document. We are looking into other integrations, so we're specifically talking with the Topcased community. They're very interested in creating and integrating RMF into their system. We've been playing in a research context With domain-specific languages, I mean, you can see that what I showed you here with the squared brackets, that's like a poor man's domain-specific language, right? So we managed to basically hook an Xtext editor directly into the requirements editor. That's all possible. We have a number of different approaches to traceability. What I just showed you uses the features of the RecIF data model to realize the traceability. So for the target objects that you have seen in the requirements editor, those were actually proxy objects that were just placeholders for the model elements. So we just store the ID and then basically pull the content on request and render it properly. So there are other approaches to traceability, and it's fairly open. I mean, you can do whatever you want to do, but there are a number of approaches, and we actually published some papers on those different traceability approaches. I put one link down there. So who's behind all that? I did some of the work in my role as a researcher at the University of Düsseldorf, and I was looking for collaborators early on and found the colleagues from ITEMIS who were in the Verde project, which is an ITEA project, and we fairly quickly joined forces. And I don't think that the project would be as far as it is had we not joined forces. I mean, I'm really, really happy that we managed within 2 years to get to becoming an Eclipse Foundation project, and there's a lot of interest as well. From Düsseldorf, we created a spin-off that will commercialize like the ideas about requirements and formal methods. So some of the things you saw there, we are looking at ways of applying them in industry, and that's basically where we are right now as far as the community is concerned. We are currently working on a roadmap. This is partly the reason why I'm here. We want to hear from you what you think about that, where you could apply it if you're working with requirements, where the strongest pain is, whether you can imagine applying the framework with your work, and if so, what are your priorities. So I encourage you to talk to us either personally today or via the forum or all the Eclipse infrastructure. Again, it's a young project. There's lots of work to be done, and we're pretty excited about this. So with that, I'd like to thank you, and I'm open for questions. No questions?
Did you try to work with RMF with the requirement repository of the size of those, the database, etc., with very big amount of requirements?
Yes, we did some performance tests, and in fact their backend underwent quite a number of changes. It wasn't that easy to actually map the EMF model to their persistence format that is required by the standard. So the first implementation actually was using one EMF model, a model transformation, and then persisting the second model. And even with that setup, the performance was like really, really promising. We completely refactored the backend, and performance is, I'd say, more than adequate as far as the backend is concerned. We currently have a number of known issues on the GUI, specifically because a number of places don't use caching where they could use it, because we wanted to show the concept before spending time on performance improvement. So, I mean, with the GUI, it starts to get painful when you have more than 1,000 requirements. But we hope that that will be solved within a few months. Other questions?
How does that fit with SysML? Reading the title of your presentation, I was expecting something about SysML, and it seems that your environment is kind of meta environment where you could, as you use B to do some requirements, you could use also something like SysML requirements instead of that.
Yes.
On top of that.
We even built a tiny prototype to see whether that's possible. I didn't show that here because 20 minutes is really not that much time, and this is just much more mature. But to answer your question there are a number of approaches. So the prototype that we built, that actually used the requirements that SysML supports and created a mapping between a SysML requirement and a spec object in this environment. So that would allow you to work with your requirements and to basically reference selected requirements in your SysML model, and also to add additional attributes to what SysML does not support. So that was the one approach. We built a prototype, just proof of concept, something to throw away. What's going on with the Topcased community is slightly different. So in the Topcased community, they built requirement support that was completely independent from the SysML requirements. And they're looking into swapping that one out for RMF. Sorry to mislead you with the abstract. Any other questions? The end. So thank you very much.